This semester, I've been working towards a project that brings together everything we've explored in IoT and AI, and that work led me to something I'm calling PackTrack. It's been a really interesting challenge to build towards, and I'm excited to walk through what it is and how I got here. So with that, let's start with where the idea actually began. For the first part of the semester, most of my exploration lived at a high level. I kept evaluating idea after idea, trying to avoid falling into the trap of adding AI just because it sounded interesting. We've discussed several examples where AI is slapped onto a product for AI's sake. I wanted something where machine learning would meaningfully improve the experience. After filtering out a lot of over-engineered concepts, I realized the real challenge was finding a problem where AI isn't just optional, but actually necessary to solve it as well. When I started looking for a direction, I bounced around and struggled to find something I was jazzed about for quite a long time. I poked at cooking because that's something I love, but every idea I came up with felt more like a nice to have rather than something AI would meaningfully improve. I looked at travel just because it's part of my life, and there's a ton of small annoyances there. And then I went down a whole rabbit hole around privacy, LLMs, and computer vision. Flock safety and OpenAI being damning examples of how privacy is not built into the foundations of these systems. Data is the name of the game, and these companies will grab all they can get by any means necessary. All of these were interesting, but none of them felt like the right fit. I kept trying to find the intersection of something I cared about and a problem that actually deserved an AI solution. Eventually, I found myself unpacking, mostly because it's such a small thing that somehow creates a lot of stress. It's chaotic, it's easy to lose track of what you already thrown in your bag, and the tools we use now don't actually verify anything. They just assume we remembered. This felt like one of the few places where vision could genuinely help, and I eagerly began thinking of how to approach the solution. The problem is visual at its core. It's about knowing what's physically inside the suitcase. I envisioned, and wanted to make a reality, a product that felt invisible and operated as a friend, checking your work over your shoulder. So once I had the problem nailed down, I started working out what the actual system needed to look like. I tried to keep it simple. A small, local processor, a fixed focal length camera, and a telescoping post that can sit on the edge of a suitcase. The idea is that it just needs to give me a consistent, overhead view of the bag while everything runs locally. Using something like a Pi Zero and a basic camera module keeps the setup lightweight, inexpensive, and easy to work with while I focus on getting the vision pipeline right. While these components might not be the final production-ready pieces, I think it'd be representative of the level of resolution and compute I would need for an effective package. When I started collecting data, I realized really quickly that packing isn't a clean or consistent environment. Real suitcase shots come with all kinds of variability. This would be represented by different fabrics, colors, lighting, angles, and the way clothes naturally fold or bunch up. Even something as simple as a shirt looks completely different depending on how someone packs it. And on top of that, everyone has their own packing habits. So the dataset had to reflect all of that messiness. The more realistic the images were, the easier it would be for the model to learn patterns that actually show up in real use. But this also meant that how I collected the data needed to be carefully considered. My first attempt at building a tracking model on top of YOLO was a straightforward approach. Take top-down photos, label every single item in the frame, and train a model to detect them all at once. You can see that in the screenshot on the right. Every visible object has a bounding box, and it looks just as chaotic as it felt. That approach forced the model to understand way too many things at once, and the F1 confidence curve on the left shows the result. The confidence was low, inconsistent, and honestly not good enough for what I needed. After talking with Arthur, he pointed out something that completely changed how I was thinking about the problem. Instead of trying to detect everything that was already in the suitcase, he suggested treating packing as a sequence of changes. So I shifted to a different approach. This meant that when the system sees no motion for a moment, it locks in that frame as the baseline. Then, when movement starts again, it identifies only the pixels that have changed. Suddenly, instead of tracking a whole scene, the model only has to classify one new item at a time. This turned the problem from a messy, multi-object detection into a much simpler single-item classification task. And once the motion settles again, whatever the model last recognized gets recorded as packed. That small shift, basically resetting the slate between items, made the whole pipeline more realistic, more accurate, and way easier for the model to reason about. But this led to the next question. All of this sounds great in theory, but how does one actually implement this technically? This is where an image preprocessing pipeline came in. The idea was to take each frame from the video and gradually strip away everything that wasn't the new object being placed in the suitcase. It starts with a standard color image, which is pulled from a single frame of the video feed. That gets cropped down to a consistent 512 by 512 window, so the model always sees the same dimensions. From there, I convert the frame to grayscale, because for diffing, color doesn't really add context. The only thing that matters is how the pixels themselves are changing over time. Then, I subtract the current pixel values from the base frame, the one captured during that moment of no movement. The subtraction highlights only the regions that have changed. Once I have that difference map, I apply a mask to pull out just the pixels associated with the new object. But the raw subtraction is noisy, so I have to run a dilation loop to fill in gaps and connect edges, followed by an erosion loop to trim back the extra noise so I only get the actual shape of the object. Finally, once the mask is stable, I extract a clean polygon crop of the object and pass that into the classifier. The resulting preprocessing pipeline was surprisingly effective at turning a very messy, real-world scene into a clean, focused representation of just the item that was added. By isolating only the pixels that change, I don't have to run a full object detector or make the model understand the entire suitcase. It cuts the problem down to something much more small and manageable. That reduction has a few important benefits. First, it dramatically reduces the compute the system needs, which matters a lot when you're trying to run everything locally on lightweight hardware. Second, it lowers the training complexity, because the model only has to learn how to classify one object at a time instead of dozens of overlapping items. And third, it actually performs better in real-world conditions where lighting, clutter, and different packing styles can confuse more complex models. This approach keeps the system focused, consistent, and much easier to scale. One of the biggest takeaways from this whole project is just how important it is to simplify. Over and over again, I had to pull the problem back to first principles and ask, what's the smallest possible version of this that actually works? And each time I did that, the solution became clearer. Right now, I have a working image preprocessing pipeline that reliably isolates new objects as they're placed into the suitcase. I also have built a clear set of requirements for the hardware prototype, something lightweight, local, and purpose-built for this workflow. On the software side, I built the foundation of a dataset that reflects real packing conditions, and I have a model that's already showing promising results with this diff-based approach. There's still a lot to refine, but I'm at a point where all the core pieces exist, and they're starting to fit together into a system that actually feels usable. Looking ahead, the next big step is expanding the dataset and adding more item classes so the system can handle a wider variety of real packing scenarios. The more diversity it sees, the more confident and flexible the model becomes. To avoid the risk of model performing well only on my clothes, I will need to begin recruiting people to capture additional clothing types and packing styles. In parallel, I'm going to start building out the companion app interface. This is the part that ties everything together and gives the user that clear, reassuring feedback as they pack. Once that foundation is in place, I can begin real user research and end-to-end testing. Seeing how people interact with the system, what they expect, and where it succeeds or struggles will be the key to shaping the next iteration. I'm excited to see where things end up. Thank you.